make sure, I don't think, most calculators these days are hard to change from degrees to something else, but you want to make sure your calculator is set to degrees. This thing is not going to make it, is it? Let me see. There we go. I see a little D at the top on my calculator. You should see DEG for degrees. You do not want to see a G for gradients. You do not want to see R for radians. You don't want that. Okay, so if your calculator is not set to degrees, you're not going to get the right answer. So for example, try this with me. My calculator, I can press sine and I can press 30, sine of 30 degrees, and if you hit equal, you should get 0.5. If you don't get 0.5, your calculator is not set to the right settings. Right now, I'm not going to worry about it. You're going to call me when I walk around later on. You're like, Mr. Dirksen, I need to change the setting. But those of you that have a calculator where you can easily change from one to the other, you have to watch every time. Okay? Some calculators have a DRG button, a degree button, so you literally can, like, even if you close the lid sometimes, it will change it. So just make sure you change that to degrees, okay? Let's go into some review stuff. So a lot of this is to review at first. Hey, you have the booklet?
Oh, yeah.
Okay. So we've got 3 types of triangles, mainly. Okay, make sure you write this down. Isosceles triangles. Anybody remember what's so special about isosceles? Crickets? No, crickets have nothing to do with isosceles triangles. It just tells you that 2 sides are going to be equal and 2 angles are going to be equal. Okay, but not any 2 angles. It's going to be the angles across those 2 sides. Okay? So for example, if you have a triangle like this, and I tell you that these 2 sides are the same, then you know that that angle and that angle are going to be the same. Just one, right? Okay. So that's isosceles. I want to make sure you write this down because this is part of geometry later on. 2 sides are equal. What's up with that an equal sign with a third wave? It's called congruency. Congruent. It's the same as equal. 2 sides are congruent. 2 angles are congruent. That's what an isosceles is. Then we've got equilateral triangle. All sides are congruent and all angles are congruent as well. So the markings indicate that those 3 sides are the same and all 3 angles are going to be the same also. Can I go back to the previous one, isosceles? Can you come with me back to the first one? When you want to make sure that these 2 are the same, the other angle will look different. For example, like it has 2 arcs like that. Same here. You can have like 2 arcs there. So you're saying these 2 are the same, but that one is different. Okay. Anybody know what the angles are equal to in an equilateral triangle? What do they always measure? Emil? 180 altogether divided by 3. So 180 divided by 3? Don't ask me that on a 60, right? 60. I appreciate that. I appreciate that. Thank you. You split them equally, yeah. But because it's a equilateral, all 3 are the same, so they're all 60 every time. Do you hear that? It's always 60. Mr. Dirksen, what about like a small equilateral triangle like this? They're all 60. What about a big equilateral triangle where like every side is 2 kilometers? Still 60. It's always 60 degrees, like the angles are always 60. Angles are always 60 degrees. This can get you out of a tough situation quite often, okay? For example, if I tell you Joe is building an equilateral triangle ramp, a ramp that is an equilateral triangle, they've given you 0 angles, right? Not a single angle is given, but as soon as I say equilateral, you're like, oh, it's one that has 60 all around. Got it? They don't have to tell you that. You have to know that, okay? Last but not least is a right triangle. Has at least 190. Okay, we have the box like that. So sometimes it goes up, sometimes it goes down. Triangles with a 90-degree angle. Can a triangle have more than a 90-degree? Can a triangle have 2 90-degree angles? No. Because how many angles does a triangle have? 3, right? And they need to add up to 180. So if you've got 2 that are 90, you're already at 180. What about the third angle? Would have to be 0, right? Can't have that. You can't have a triangle with more than 180 altogether. You can't have a triangle with less than 180. It has to be exactly 180. Anything more or less does not exist. Okay? If I were to give you 3 angles and they do not add up to 180, and I told you give you the pieces, it's like go make that triangle, you'd be like, Mr. Dirksen, like we can't close it at this one. We can't because it's just impossible. Okay? I wish I could actually show you, but maybe I will. Maybe I will. I'll use Desmos or something like that. The sum of interior angles is always 180. Please remember this. Okay? So A, B, C, A plus B plus C is always 180 degrees. Okay, how is this going to be helpful? If I gave you one like this is 50, this is 30, and you would want to know what that angle is there. Then, how can I find that angle? Let's give it a letter. I'm going to call this B, angle B. Angle B will be 180 minus 30 minus 50. That is 100 degrees. What kind of an angle is that? There's 3 types of angles. Did you know that? Let's do that on the side. Less than 90 is acute. Equal to 90 is right. Can you see that? Yeah. Greater than 90 is obtuse. Some of you might need to add that to your study sheet. Oops. Sorry about that, guys. So sum of triangles is always 180. Right? You've got acute, right, obtuse angles. Supplementary angles. What are supplementary angles? Here's the definition. 2 or more angles that add up to, anybody know? Supplementary adds up to what? How many degrees? 180. And here's your example, okay? A classic will be, you will notice some sort of a straight line, and then you'll have another line intersecting it, okay? And so if this is 150 degrees, what is this one over here? 30. Why is that? A straight angle is always equal to 180 degrees. And I want you to have this on your study sheet. Straight angle is equal to 180. Have this example right next to this. Like, make this all one big box. This is going to come in really, really handy, guys, knowing this property. Okay? Watch this. I'm going to use a ruler for this. You don't have to, but sometimes you might have a triangle come like this, and then it might be intersected like that. Okay? If this is 80, I would like you to understand that, oh, wait a minute. Wait a minute. Do you see this straight line here? Okay? You should recognize that that's 180. 180 together. So if this is 80, then this is 100. This might not show up today as much, but it will show up down the road. Okay? What are complementary angles? It's two or more. I will use this for angles, okay? I'll use that notation. Two or more angles that add up to, anybody? $90. I have to go talk to Mr. Isfeld and Mr. Neufeld. It's like, what are you talking about in trigonometry? That's okay. I don't care. Let's review it now, right? But you know the trick for me to remember? It is right to compliment someone. It is the right thing to do to give someone a compliment. If you think of it that way, it's like, oh, right, it's 90, compliment, right? Compliment goes with 90, okay? How is that handy? If you ever have one of these, right, you have a 90 there, these two lines get together and they form a 90. Let's cut it up. Let's cut it up. Let's assume that there's another line going this way. If I told you that this is 30 degrees here, this opening, what is this going to be? 60. Because we know that if there's a 90 at this corner and we cut it up and we figure out that this is 30, we just subtract it and we get the other one there. So this is also one I would have on my study sheet under trigonometry, of course. Okay? Next, I want you to write, to add something to this. You ready? This is X, this is Y, this is Z, this is K, and for the side length, we're going to use number 1, number 2, and number 3. Fill that in, please, this triangle, okay? There's something in I find that annoying. I find it hard to work with, so I try to find different letters for it. But if you have a 3-letter notation, is for angles, okay? Angle notation, where there's 3 letters, that's this. For sides, we use 2-letter notation. That's this, okay? Angles, sometimes we use 3 letters. That's that. So if I were, basically I want you to identify, okay? Angle ABC, where is it? Don't tell me. Okay, don't tell me yet. Angle ABC. Where's A? So you read it like this, ABC. A to B, right? A to B and then to C, correct? So you've created these 2 segments, A to B, B to C. You connect those 2. So which angle am I referring to in this case? Angle K. I just put the letter there. So what I want you to do is, I want you to put the correct letter next to each 3-letter angle notation. And then I also want you to identify which BC, side BC, what number is it? Side DB, what number is it? Side DC, which number is it? Okay, can you do that real quick? Just to make sure you know how to do that. Okay, keep going. Angle CBD, C to B to D, right? So C to B and then to D. You've made these 2 lines. You connect them. So angle Z. Angle CDE, CDE. It's right here. It's angle X. Angle BDC, B to D to C, that is angle Y. Okay, angle Y goes there. Can I please ask you to do this to make your lives easier when you work with a question and they use this kind of notation? Go find it, put a letter of your choice in there, and make sure you also label it right here by the questions. Like I'm calling this one K. I don't want to deal with a 3-letter notation, okay? Next, if you just have 2 letters, BC, it's just this segment right here, it's just 1, okay? D to B, it's this stretch is 2, and D to C is 3. Okay, that's all you need to do. I just want you to be familiar with it. It's not such a big deal. I'm sure most of you remember that, okay? But sometimes the province does that. They use those a different notation. Keep going. Page 3. We use caps for angles, lowercase for sides across the angle. So example, sketch triangle X, Y, Z. Okay? If I ask you to sketch it, I don't need it to scale. You just make a triangle that looks like that. Just make it look like a triangle. Start anywhere you want and go either clockwise or counterclockwise. Okay? So X, Y, Z. Capitals. So convention has it that if this is angle X, then we go lowercase x across from it. If this is capital Z, then we go Z there. If this is capital Y, we go lowercase y. So that is our convention on labeling. Okay, so if I ask you find side Z, you should know that I'm trying to find the side that's across from angle Z. Okay? I don't think that's new, but okay, there we go. Angles of elevation and depression. Do you remember this one? Your teachers talked about it, hopefully. Don't get too excited. I know it's quite something. You won't be able to forget it anytime soon. This is how I do it. It's kind of cheesy, but follow me here anyways, okay? They would never put my artwork in the hallways. Let's just put it that way. Okay, that's just how art is for me. It's not something I'm good at. But this is the most important line when you're doing elevation or depression. It's called the horizontal. Okay, horizontal. That is the most important line of all the lines you're going to make when you create one of these two. I will say must have, okay? Must be present. Sometimes I make it dashed because it's not explicitly mentioned, but nonetheless, here we go. If you look at something up here, like a bird or a tree or a mountaintop or something, you're looking, this is your horizontal, right? You're looking straight ahead. If you tilt your head upwards and you look at something up, we measure from the horizontal going up, actually make an arrowhead. This is the angle of elevation. Got it? So your triangle would look like a regular triangle. If you're looking at something down here, so let's say this is a bug crawling on the ground, or you're actually top of the hill looking down, or you're flying a plane, you're looking down. Guess what? There's a horizontal. I'm going to stop. I'm going to pause here for a reason. Where do I start from? The horizontal, right? I don't start from the vertical, do I? I start from the horizontal. Okay, hopefully that sticks. From there, looking down, this from the horizontal going to the line of sight looking down, that's the angle of depression. Okay, so that's something to remember. So let's give you a quick example here. Example, if a question mentions the angle of elevation to the top of the tree is, let's say, 40 degrees. If a question just mentions it, hey, you're walking, you stop, you see a tree, the angle of elevation is 40 degrees. You should immediately recognize, okay, what do I start with? The horizontal. That's the ground for me. I look at the tree, right? The angle of elevation will be measured from the tree to the top. You get your 40 right there. Boom. Another example for depression. A pilot sees a ship at an angle of depression of 25 degrees. How would you sketch that triangle? This is the pilot. Let's call that P. And where's the ship? Usually down, right? If you're a pilot, usually the ship is down, in my world at least. I think everybody would agree this is where the pilot is looking at, correct? You're flying up here, looking down. I think everybody would agree with that. But remember, where do we start measuring the angle from? Horizontal, right? So I will make this a dashed line because it's not like, you know how on the ground you have a physical ground, like it's there, it's a solid line. Here it's kind of like, it's not really, you can call it the clouds, right? So this is the angle of depression. That's where the 25 degree goes. Okay? And so I'm going to highlight that the 40 in this case went in between, of course, right? And here, the 25 went in between here. That is the angle of depression. So there we go. Let's keep going. Oh, both of them are missing the most important one, the horizontal. Okay, the most important one for both of them, for them to work, it's the horizontal. Okay, keywords. I'm about to start the actual math for today, okay? Some of you need a reminder where north and south, east and west is. North, south, east, west. So this is west and this is east. I know that your teachers tried all kinds of funky stuff, never eat soggy wieners, blah, 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 blah. I think everybody knows where north and south is. Just make sure this spells we, not you. If it says EW, that's you, right? Don't do it. We, good, okay? Example, a tree is due east of you. What if a question says a tree is due east of you? That means that you are here, and where is east? It's to the right. This is where the tree goes. Okay, that's all I need you to know that, okay? And last but not least, I know it's hard, but let's try our best here. If you, an example here, you know what? I will first give you the formula. Distance is, sometimes this formula will come in handy. Speed times the time. Example, you walk at 3 kilometers per hour. How far after 1.5 hours? We'll go distance is equal to what's the speed? It's 3, right? Times 1.5. So you walked 4.5 kilometers in 1.5 hours, if that's the speed you're walking in. So that comes in handy sometimes. So keep that in mind.